Okay, so for the lesson today, we have 2 tasks. We're going to watch this video and complete or correct our simulation from yesterday, and then we're going to complete a graphic organizer about a system that we've already seen. So first thing first, we are going to model, I already got started over here. We're going to model the molecules in the cold, room temperature, and hot. First, I'm just going to model how they're spacing, okay? How far apart they are. So in the solid, we're dealing with molecules that are much closer together. Not solid, sorry, cold, in the cold. In the room temperature, we're dealing with molecules that are more spread out. Okay, and then in the gas, they're really spread out. Okay, now I'm going to show their movement by adding some lines. So these guys are kind of more in place. They're not really moving as much past each other, and they're slowly moving. As the thermal energy is added, okay, and that's happening when we go from cold to room temperature, from room temperature to hot. So when it's added, what happens is the speed of the molecules increases. Okay, so here's our speed. Then when we get to the gas, they're like going bonkers. Okay, so let's add those. I'm trying to show they're kind of going in every which direction. Okay, so now we have to come down here and say what causes the alcohol to rise, what causes the effect when the thermal energy is added. We are going to use these words. So as thermal energy is added, the molecules in the alcohol move faster. I can see that here. So as thermal energy is added, remember we're going this way, we're adding energy. They are moving faster. I can see that from my lines that I modeled up top here. And this causes the volume to increase. Remember, volume is the amount of space something takes up. Amount of space. Okay, so, and I can see that in my picture here. Now, I can see that not only in the molecules, but I can see it, my level that I should have seen is, for each of these, is we see an increase as the molecules move faster. Okay, and then the last piece here is we just have to make sense of what's going on down here using some new vocabulary. So heat is a transfer of thermal energy from a hotter object to a colder object. So heat, lots of information here, is the transfer of thermal energy from hotter to colder. Okay, until the total thermal energy in both objects is the same. Same is like equal. Okay, so, and that's total thermal energy. I'm just doing this to kind of make sense of stuff. Use the words hot object, colder object, and thermal energy in an arrow to show the heat in the picture. Okay, so I'm going to label this burner. And then this one pan. Okay, just to keep myself straight. And so the hotter object is my burner. Or just hot object, I guess. And then colder object. I'll put a TR on there. Okay, and then I need to show the flow of thermal energy. So I'm going to show it as red. And it's flowing from the hotter object to the colder one. And we call that thermal energy. Okay, and this is a really nice review because we're going to take this idea of a thermometer, we're going to put it in a glass beaker, and we're going to model that as a system to help understand this phenomenon a little bit more. So, on this one, we are going to, sorry, I did not mean to have all this on here. Okay, pretend you didn't see that. Okay, we are going to go through and just first make sense of what this is. So a system is it's basically a group of parts that work together. A group of parts that work together. And a system model, is interesting because it's another type of model that allows scientists to study something that's really complex. And they do this by creating a imaginary boundary to make something simpler and to kind of almost zoom in and focus on just one concept. So if we look at the concept we're focusing on, it's the phenomenon of why the red liquid rises in the thermometer as the water's heated. And so that's what we're going to show or model in this systems model. And the boundary is going to be where the system begins or ends. And in this case, scientists can decide. You can decide where you want your boundary to start or begin, or start or end. And so for us, we're going to say that the boundary is, we're going to call anything inside of the beaker part of the system, and the outside of the beaker will be not part. So I'm going to draw a line here to show my system boundary. Okay. And then next, what I'm going to do is I'm going to label some of the components. And components is a fancy way to say parts. What are the parts in this? Well, let's just, even if it's like, obviously, let's label it anyway. So thermometer. Okay. And we've got the beaker. And maybe I'll say glass beaker just to remind you what beaker means. It's just a fancy word for like a measuring glass. Okay, and then we've got the burner. And let's see, what else do we have going on here? Well, what do you think they're trying to get us to model here? It's pointing to the red. So this is going to be the alcohol. Alcohol. But not just the alcohol. If we're zooming in like this, we want to see the molecules. Okay. And just a side note, the molecules are unobservable. So we can't observe those just with our naked eye, okay, without any special tools. But I know they're there, okay? And we know they're there because we saw that as the temperature increased, that the molecules moved up. Or as the heat increased, thermal energy increased, the molecules moved up. Okay, sorry, I was choosing my wrong word there. So I'm going to just kind of get the stuff in my components first so I can think about this system. So the next thing is we've got molecules. Now I got to draw them. Okay. Well, look at how high this is. That means that these are going to be pretty spread out and they're going to be moving pretty quick. So I'm going to show moving pretty quick. Okay. So, and the type of energy that comes from moving is kinetic energy. We read about that on Friday. So kinetic energy. I'm going to go ahead and label that because that's happening. And maybe that's just moving energy. Okay. And then last, let's see. I want to show what's happening here. Well, we have energy, thermal energy. Actually, maybe I want to show that with this. Thermal energy is being transferred. It's being transferred. Is transferred from one system to the other. This is the burner, is its own system, but not the one we're modeling. Okay, and then this is let's just call it the beaker system or the thermometer system. Thermometer. Try that again. Sorry guys, it's kind of late here. Thermometer system. Okay, so this whole thing here is my thermometer system. Okay, and then so now we got our parts, and let's think about what's being added to this system. So if we look at the burner being a different system, and the thermometer being its own system, I knew I wasn't spelling that right. Then we need to get in what's being added to the system. So fix that. And one last time. Thermometer system. Okay, so what's being added? Well, we can see here that thermal energy is being added to the system in the way of the burner. Okay, and I can see over here that one of the results of, or one of the things exiting the system is actually water vapor. This is water vapor. Okay. So water vapor, and you might go, what? What's water vapor? Well, that's like the water that collects on the top of a lid when you boil water. It's the gas form of water. Okay, and then the last thing that we're going to do is, now that I kind of modeled how we model a system, then your next task is to go here. You have 4 words. You need to read through this carefully. If you want to annotate, you could do that, but read through it carefully, and you're going to fill in the words that complete the sentence. So blank energy is transferred into the system. Well, let's think about what kinds of energy are there. Thermal and kinetic. Well, let's go back up to our model. What kind of energy is transferred in? Thermal. So boom, 1 down, 3 more to go. Okay, please complete this so you're ready for your assessment next week. Thank you for listening.